Hello everyone. So let's continue where I left. How does the web work? How does the web work? Introduction. Before you can understand how to program the web, you need a more rigorous understanding of the web itself than you likely have now. These concepts provide a more holistic understanding of the ecosystem in which you will be working and will enable you to talk intelligently with other developers about your work. Lesson overview. This section contains a general overview of topics that you will learn in this lesson. Describe what the internet is, describe what packets are and how they are used to transfer data, understand the differences between a web page, web server, web browser, and search engine. Briefly explain what a client is, briefly explain what a server is, explain what IP addresses are, explain what DNS servers are. So let me open these links one by one. I'll also add time stamps, I think what they are called. Okay, there are two options: interaction, read about, or watch us. Okay, I'll choose one. So they are loading. So what I was saying, I'll add timestamps to the video so one can skip to a specific part, and I'll also add these links also in the description section. So let's continue. How does a DNS request work? Okay, wait a minute. Watch this BBC short. Let me, I'll get confused, I guess. Let me close them and then reopen. Okay, it's YouTube. I think it's gonna take some time to load because of my internet connections. It's taking quite a bit of time. Read this article from Mozilla on how does the internet work. So get some time to load. Okay, I think we are almost there. Let's open this. How does the internet work? This article discusses what the internet is and how it works. Let me so prerequisites none, but we encourage you to read the article on setting project goals first. Objective: you will learn the basics of the technical infrastructure of the web and the difference between internet and the web. Summary: the internet is the backbone of the web, the technical infrastructure that makes the web possible. At its most basic, the internet is a large network of computers which communicate all together. The history of the internet is somewhat obscure. It began in the 1960s as a US Army funded research project that evolved into a public infrastructure in the 1980s with the support of many public universities and private companies. The various technologies that support the internet have evolved over time, but the way it works hasn't changed that much. Internet is a way to connect computers all together and ensure that whatever happens, they find a way to stay connected. Okay. Do I have to also go through active learning? Yeah, I have to. Active learning, how the internet work in 5 minutes. Huh. I think I should choose this first. Out of the internet. Okay, there are a document. Sorry, there is a document version of how does the internet work. Rather than this, I think it will take up to 10 minutes, but let's go with the videos. Okay, it will once again take some loading time. Okay, it didn't took much of a time. So let's start by watching these YouTube videos. I hate sometimes how my internet works. I think I might be.
How does the internet work? The video you are watching now traveled.
Okay, let me increase the quality of the video first. And I forgot to plug in my mic, so the audio will sound a bit different than usual. Okay, let me. Why does internet work this slow? Uh, Let me then start.
How does the internet work? The video you are watching now traveled thousands of miles from a Google data center to reach you. Let's learn how the internet works by getting to understand the details of this data's incredible journey. The data center, which can be thousands of miles away from you, has your video stored inside it. How does this data reach your mobile phone or laptop? An easy way to achieve this goal would be with the use of satellites. From the data center, a signal could be sent to the satellite via an antenna. And then from the satellite, a signal could be sent to your mobile phone via another antenna near to you. However, this way of transmitting signals is not a good idea. Let's see why. The satellite is parked nearly 22,000 miles above the Earth's equator. So, in order for the data transmission to be successful, the data would have to travel a total distance of 44,000 miles. Such a long distance of travel causes a significant delay in receiving the signal. More specifically, it causes huge latency, which is unacceptable for most internet applications. So if this video does not reach you via a satellite, then how does it actually get to you? Well, it is done with the help of a complicated network of optical fiber cables, which connect between the data center and your device. Your phone could be connected to the internet via cellular data or any Wi-Fi router, but ultimately, at some point, your phone will be connected to this network of optical fiber cables. We saw at the beginning that the video you are currently watching is stored inside a data center. To be more specific, it is stored in a solid-state device within the data center. This SSD acts as the internal memory of a server. The server is simply a powerful computer whose job is to provide you the video or other stored content when you request it. Now, the challenge is how to transfer the data stored in the data center specifically to your device via the complex network of optical fiber cables. Let's see how this is done. Before proceeding further, we should first understand an important concept, which is the concept of an IP address. Every device that is connected to the internet, whether it is a server, a computer, or a mobile phone, is identified uniquely by a string of numbers known as an IP address. You can consider the IP address similar to your home address. That is, the address that uniquely identifies your home. Any letter sent to you reaches you precisely because of your home address. Similarly, in the internet world, an IP address acts as a shipping address through which all information reaches its destination. Your internet service provider will decide the IP address of your device, and you are able to see what IP address your ISP has given to your mobile phone or laptop. The server in the data center also has an IP address. The server stores a website, so you can access any website just by knowing the server's IP address. However, it is difficult for a person to remember so many IP addresses. So to solve this problem, domain names like youtube.com, facebook.com, etc. are used which correspond to IP addresses, which are easier for us to remember than the long sequence of numbers. Another thing to notice here is that a server has the capability of storing several websites, and if the server consists of multiple websites, all the websites cannot be accessed with the server's IP address. In such cases, additional pieces of information, host headers, are used to uniquely identify the website. However, for the giant websites like facebook.com or youtube.com, the entire data center infrastructure will be dedicated to the storage of the particular website. To access the internet, we always use domain names instead of the complex IP address numbers. From where does the internet get IP addresses corresponding to our domain name requests? Well, for this purpose, the internet uses a huge phone book known as DNS. If you know a person's name but don't know their telephone number, you can simply look it up in a phone book. The DNS server provides the same service to the internet. Your internet service provider or other organizations can manage the DNS server. Let's have a recap of the whole operation. You enter the domain name. The browser sends a request to the DNS server to get the corresponding IP address. After getting the IP address, your browser simply forwards the request to the data center, more specifically to the respective server. Once the server gets a request to access a particular website, the data flow starts. The data is transferred in digital format via optical fiber cables, more specifically in the form of light pulses. These light pulses sometimes have to travel thousands of miles via the optical fiber cable to reach their destination. During their journey, they often have to go through tough terrains, such as hilly areas or under the sea. There are a few global companies who lay and maintain these optical cable networks. These visuals show how the laying of optical fiber cables is done with the help of a ship. A plow is dropped deep into the sea from the ship, and this plow creates a trench on the seabed into which is placed the optical fiber cable. In fact, this complex optical cable network is the backbone of the internet. These optical fiber cables carrying the light are stretched across the seabed to your doorstep, where they are connected to a router. The router converts these light signals to electrical signals. An Ethernet cable is then used to transmit the electrical signals to your laptop. However, if you are accessing the internet using cellular data, from the optical cable, the signal has to be sent to a cell tower. And from the cell tower, the signal reaches your cell phone in the form of electromagnetic waves. Since the internet is a global network, it has become important to have an organization to manage things like IP address assignment, domain name registration, etc. This is all managed by an institution called ICANN, located in the USA. One amazing thing about the internet is its efficiency in transmitting data when compared with cellular and landline communication technologies. This video you are watching from the Google Data Center is sent to you in the form of a huge collection of zeros and ones. What makes the data transfer in the internet efficient is the way in which these zeros and ones are chopped up into small chunks, known as packets, and transmitted. Let's assume these streams of zeros and ones are divided into different packets by the server, where each packet consists of 6 bits. Along with the bits of the video, each packet also consists of the sequence number and the IP addresses of the server and your phone. With this information, the packets are routed towards your phone. It's not necessary that all packets are routed through the same path, and each packet independently takes the best route available at that time. Upon reaching your phone, the packets are reassembled according to their sequence number. If it is the case that any packets fail to reach your phone, an acknowledgement is sent from your phone to resend the lost packets. Now, compare this with a postal network with a good infrastructure, but the customers do not follow the basic rules regarding the destination addresses. In this scenario, letters won't be able to reach the correct destination. Similarly, in the internet, we use something called protocols for the management of this complex flow of data packets. The protocols set the rules for data packet conversion, attachment of the source and destination addresses to each packet, and the rules for routers, etc. For different applications, the protocols used are different. We hope this video has given you a good understanding about how the internet works. More specifically, about the amazing journey of data packets from the data center to your mobile phone. Please don't forget to support us at patreon.com. Thank you.
Okay, let me recheck this specific part. On this one. Yeah.
Complex flow of data packets. The protocols set the rules for data packet conversion, attachment of the source and destination addresses to each packet, and the rules for routers, etc. For different applications, the protocols used are different.
Okay.
We hope this video has given you a good understanding about how the internet works. More specifically, about the amazing journey of data packets from the data center to your mobile phone. Please don't forget to support
how
us
does the internet
at
work?
patreon.com.
Most of us know how
Thank
to
you.
use the internet without actually understanding how it works, sort of like electricity in your home.
I think my system's getting stuck on a loop. It's not responding. Or maybe the data packages are lost, that's why. And start. This was the second video they referred.
So, how does the internet work? Most of us know how to use the internet without actually understanding how it works, sort of like electricity in your home. You use it every day, but may not understand the mechanics behind it. And if the electric grid is difficult to understand, then the internet must be impossible, right? Wrong. In the next few minutes, I'll put you in the top 10% of people who understand how the internet actually works. For SecurityCatalyst.com, I'm Aaron Titus. Whenever most people think of the internet, this is what comes to mind. The internet is not a bubble cloud, even in the new age of cloud computing. The whole fuzzy cloud picture was created by people more concerned about job security than education. This is the internet. The internet is a wire, actually buried in the ground. It might be fiber optics, copper, or occasionally beamed to satellites or through cell phone networks, but the internet is simply a wire. The internet is useful because two computers connected directly to this wire can communicate. A server is a special computer connected directly to the internet, and web pages are files on that server's hard drive. Every server has a unique Internet Protocol address, or IP address. Just like a postal address, IP addresses help computers find each other. But since 72.14.205.100 doesn't exactly roll off the tongue, we also give them names like Google.com, Facebook.com, or SecurityCatalyst.com. So this is how it works. Your computer at home is not a server, because it's not connected directly to the internet. Computers you and I use every day are called clients, because they're connected indirectly to the internet through an internet service provider. Here we'll pretend that this is my home laptop and I'm using DSL. Now let's pretend that I want to visit AOL.com, which is coincidentally both a server and an ISP. I hop onto my laptop with DSL, go through my ISP, onto the internet, and look at AOL.com. My computer connects with AOL.com, and I can look at its web pages. Now, let's say that I want to send an email to Aunt Ruth. Aunt Ruth has AOL dial-up from home, and I've got a Gmail account. I log on to gmail.com and compose a message to Aunt Ruth's email address, auntruth@aol.com. Once I click send, gmail.com sends the email to AOL.com. The next day, Aunt Ruth dials into AOL servers and retrieves the email. Whenever an email, picture, or web page travels across the internet, computers break the information into smaller pieces called packets. When information reaches its destination, the packets are reassembled in their original order to make a picture, email, web page, or tweet. Okay, so imagine you're at work sitting next to your boss, and you're both surfing online. Your boss is doing market research, and you're updating your Facebook profile. You're both sending packets back and forth over the internet. But what's to keep your packets from accidentally ending up on your boss's screen? That could be embarrassing. The solution to that problem is IP addresses and routers. Everything connected directly or indirectly to the internet has an IP address. Everything. That includes your computer, servers, cell phones, and all of the equipment in between. Anywhere two or more parts of the internet intersect, there's a piece of equipment called a router. Routers direct your packets around the internet, helping each packet get one step closer to its destination. Every time you visit a website, upwards of 10 to 15 routers may help your packets find their way to and from your computer. Imagine each packet as a piece of candy wrapped in several layers. The first layer is your computer's IP address. Your computer sends the packet to the first router, which adds its own IP address. Each time the packet reaches a new router, another layer is added until it reaches the server. Then, when the server sends back information, it creates packets with an identical wrapping. As the packet makes its way over the internet back to your computer, each router unwraps a layer to discover where to send the packet next until it reaches your computer and not your boss's. And that's how the internet works, in 5 minutes or less. And you're now easily in the top 10% of people who understand the basics of the internet. If you found this video helpful, check out securitycatalyst.com for all kinds of ideas on how to protect your information. I'm Aaron Titus.
So let's close this tab and go to this first link. Yeah, the BBC short that was loading at that time. Let me increase the resolution. It's auto at 720p, but it may get decreased to 480p or 320 according to my internet connection, and I don't want that to be happening. So let's start.
Every single day, we upload 4 million hours of video to YouTube. We send 682 million tweets. We post over 67 million Instagram pictures. 4.4 billion of us use the internet, and collectively we create 2.5 exabytes. That's 2.5 million terabytes, or 2.5 quintillion bytes of data every single day. And a significant proportion of all of that data, searches, news, messaging, social media, video streaming, goes through here. This is Telehouse North, one of the most important parts of the internet backbone. It's one of 4 buildings here in London full of computers, cables, cooling equipment, and sheer geekery. The internet was built on many earlier ideas, but the big one happens exactly 50 years ago this week.
The work had origins in 1969 when the American Defense Department, specifically the Defense Advanced Research Projects Agency, decided that it needed a network to connect about a dozen university computer systems together in order to promote sharing of information and acceleration of research in artificial intelligence. And so they promoted the design and development of a packet switch network, which they called ARPANET.
On October the 29th, 1969.
Okay, did you hear that? This man, co-inventor of the internet, mentioned artificial intelligence. So the AI was still there back then. Wow, amazing. Let's continue.
At 10:30 in the evening, the first message was sent over ARPANET. A computer at the University of California in Los Angeles sent a word to Stanford Research Institute in San Francisco. The word was log in, although the system crashed before they got to the G. Nevertheless, those two nodes became hundreds and then thousands and then millions of connections. A global network of networks now consists of over 1.2 million kilometers of submarine cables, sometimes laid as deep as Mount Everest is high. These connect massive server buildings, and immeasurably more smaller cables connect those to individual computers. An interconnected network that Vint Cerf and Robert Kahn named the Internet. It's important to understand that the Internet is not the World Wide Web. The web is a great invention. It's the way that data, web pages, services, and documents are arranged, accessed, and addressed. But all of that sits on top of the hardware that is the Internet, which allows many, many networks to talk to each other in a really clever way. So, say you want to watch a cute video of a cat. Well, your request to see the video shoots out of your device along regional networks and at some point races through Telehouse North and off across the globe to where the video is stored. And this is where it gets really clever. See, sending the whole video in one go down one route will likely mean that it will get stuck in traffic and take ages. So the video is torn apart, broken up, split into little packets, and each one makes its own way back down different routes. And when they start arriving back at your device, they're juggled into the right order. And once enough of the start of the video has arrived, there's your cat, as cute as you wanted. This is how information spreads across the world. But unfortunately, it's not always the right information.
We have a tough problem ahead of us, which is to try to help people distinguish good quality information from bad quality information.
One of the big problems seems to be that these days we're all locked in our own echo chambers. The information we hear comes from people that we've chosen to listen to. So as well as democratizing information access, the internet seems to have isolated us from rational debate and made it really hard to distinguish facts from opinions from fake news.
Okay, and it's done. So let's go to the third video, how the internet works in 5 minutes. Hey, I think I watched it already. Let me see. Read up on the differences between a web page, a web server, and a search engine. Watch this Google short explaining what a web browser is. Okay, I'll go to this. Yeah, I've already watched this, so I'll skip it. And what is different between web page, website, web server, and search engine? So let's get started. Here is a summary. As with any area of knowledge, the web comes with a lot of jargon. Don't worry, we won't overwhelm you with all of it. We have a glossary if you are curious. However, there are a few basic terms you need to understand at the outset, since you'll hear these expressions all the times as you read on. It's easy to mix these terms since they refer to related but different functionalities. You will sometimes see these terms misused in news reports and elsewhere, so getting them mixed up is understandable. We'll cover these terms and technologies in more detail as we explore further, but these quick definitions will be a great start for you. Web page. So, a document which can be displayed in a web browser such as Firefox, Google, Chrome, Opera, Microsoft Edge, or Apple Safari. These are also often called just pages. Website, a collection of web pages which are grouped together and usually connected together in various ways, often called websites or a site. Web server, a computer that hosts a website on the internet. Search engine, a web service that helps you find other web pages such as Google, Bing, Yahoo, or DuckDuckGo. Search engines are normally accessed through a web browser. Example, you can perform search engine searches directly in the address bar of Firefox, Chrome. Okay, this is address bar here, etc., or through a web page, example bing.com or duckduckgo.com. Let's look at a simple analogy, a public library. This is what you would generally do when visiting a library. Find a search index and look for the title of the book you want. Make a note of the catalog number of the book. Go to the particular section containing the book, find the right catalog number and get the book. Let's compare the library with a web server. The library is like a web server. It has several sections, which is similar to a web server hosting multiple websites. The different sections, science, math, history, etc., in the library are like websites. Each section is like a unique website. Two sections do not contain the same books. Okay, the book in each section are like web pages. One website may have several web pages. Example, the science section, the website will have books on heat, sound, thermodynamics, statics, etc. Web pages can each be found at a unique local URL. The search index is like the search engine. Each book has its own unique location in the library. Two books cannot be kept at the same place, which is specified by the catalog number. Okay, I won't deep dive on the topic, but I do have MDN web docs pinned. Where are it? Yeah, here it is. It's already pinned on my pinned pages, so I'll get to it if I get stuck, or in near future I need to deep dive into the topic, but for now I'm not going into it. There is an active learning available yet. Please consider contribution. What is this? Maybe it's a video or maybe not. Let it open. Okay, okay. This is not what I was looking for. So, no. Let's continue. Watch this Google short explaining what a web browser is, then find out what web browsers are you using right now. So I do know this, like I'm using Mozilla Firefox. Read about how one part of the web interact with another, and read about or watch a DNS request in action. So read about, and I'll click on read about or watch. I'll open both, but I'm gonna choose to watch. So okay, client and servers, request response, computers. Okay, okay. What was it about? First I have to watch the Google short, then I'll go with other articles, I guess. Okay, read about or watch DNS request in action. So this is a DNS request, I guess. Maybe. Yeah. It's a DNS request. Okay, this one is DNS request. How does a DNS request work? So this article is this. Read about how one part of the web interacts with another. Okay. So let's for DNS request, wait a minute, why it is showing that the video is played in past till 45 seconds. Okay, I had my internet connection. I think one day I have to go and sit on top of a tower to like get network. I think it will take some time. DNS made easy videos. Okay, maybe I have watched this video in past, but I'll once again rewatch it. Let me set it to 720. And let's start from 0. Why this happens? YouTube is now full screen, so I'm going at the starting point and play. It should work.
Today, there are people trying to dictate how the domain name system, known as DNS by the cool kids, and by association, the internet as a whole works. Unfortunately, many of these powerful individuals and others don't understand what exactly DNS is. This video is for them and for anyone else that wants to learn about DNS. We are going to go over the basics of what DNS is, how it works, and how if you use the internet, it affects your life daily. Think you know what DNS is already? Stick around anyway, you might learn something. Here at DNS Made Easy, we love DNS. We could obviously spend hours going into each and every detail, but we're only explaining the basics here. If you ever decide to run for public office someday and want to make decisions on DNS, this'll help. Okay, let's begin. The domain name system is indisputably one of the most important and overlooked parts of the internet. Without DNS, the internet as we know it today would collapse, and we would all be licking stamps to pay our bills, driving to an actual store to purchase something, reading the newspaper to see what movies were showing, or buying little round pieces of plastic called CDs to get our music. How can we say that DNS is this important? We all know, or should know, that the computers that make up the internet are set up in large networks that communicate with each other via underground or underwater wires and are identified using strings of numbers known as IP addresses. Since the majority of us lack the mental capacity to sort through and retain hundreds of numerical series, DNS is used to translate an actual name into these numbers. But how does the domain name system work? In a web browser, let's say you enter the URL www.example.com as an example. When you type www.example.com into your address bar, you will actually be looking for www.example.com . Yes, there is a dot at the end of the domain name, one that you never see and one that you never type. When you type in www.google.com, you are actually going to the page www.google.com . Seriously, try it out. Oh wait. Okay, look, that's long enough. Anyway, that end dot represents the root of the internet's namespace. The root. Why is this so important? Because this is where it all begins. When you first search for www.example.com , your browser and your operating system will first determine if they know what the IP address is already. It could be configured on your computer, or it could be in memory, what the cool kids call cache. No, not cache as in cache money. The memory cache. C-A-C-H-E. Keep up, will you? Anyway, so the browser asks the operating system, and they both don't know where www.example.com is. What happens next? The operating system is configured to ask a resolving name server for IP addresses it does not know. The resolving name server is the workhorse of the DNS lookup. It is either configured manually or automatically within your operating system. Your operating system asks, or queries, the resolving name server for www.example.com. The resolving name server may or may not have this in memory, or, cache. Yes, the C-A-C-H-E one, not the... Never mind. For the sake of this demonstration, it does not. The only thing that all resolving name servers should know is where to find the root name servers. Yes, that enigmatic dot that appears at the end of every domain name you type into that address bar. The root name servers will reply with,
I don't know, but I do know where to find the com name servers. Try there.
The com name servers are called the top-level domain name servers, or TLD name servers. The resolving name server then takes all of this information from the root name servers, puts it in its cache, and then goes directly to the COM-TLD name servers. When the resolving name server queries www.example.com, the TLD name servers respond,
I don't know, but I do know where to find the example.com name servers. Try there.
This next set of name servers are the authoritative name servers. So how did the CommTLD name servers know which authoritative name servers to use? With the help of the domain's registrar. When a domain is purchased, the registrar is told which authoritative name servers that domain should use. They notify the organization responsible for the top-level domain, the registry, and tell them to update the TLD name servers. So, anyway, the resolving name server takes the response from the TLD name server, stores it in cache, and then queries the example.com name servers. At this point, the authoritative name server will say, "Hey, I know where that is! Tell your browser to go to the IP address 192.168.1.1. The resolving name server takes this information from the authoritative name server, puts it in cache, and gives a reply to the operating system. The operating system then gives this to the browser, and the browser then makes a connection to the IP address requesting the webpage for www.example.com. Pretty cool, huh? While the process seems complex, and believe me, it is, this whole cycle takes less time than it takes you to blink an eye. DNS was designed to work extremely fast and efficiently. It is an integral part of the internet. Once you understand this, you can clearly see the many different facets and organizations that are responsible for a single DNS lookup. One lookup! There's a resolving name server, the root name server, the TLD name servers, and the authoritative name servers. If anyone were to dramatically change or filter any part of the DNS process, it could lead to disaster. This is why we believe the people with the power to pass legislation need to understand what's at stake before making decisions that could drastically affect how the internet works. If you want to learn more about DNS and see the DNS process in action firsthand, type www.dnsmadeeasy.com into your browser. Brought to you by DNS Made Easy, providing enterprise authoritative DNS for over 10 years. If DNS Made Easy isn't already managing your domain, contact us to see how we can lower your cost, increase your uptime, and increase your speeds.
Well, this was actually fun. I kinda liked it. So let's subscribe to the channel and go to what is a browser.
The most important program on your computer is your web browser, and yet most people aren't sure which web browser they're using or what a web browser even is. Let me try to explain by first telling you what a web browser is not. A web browser is different from Windows or Mac, which are systems that allow you to manage files and programs. And it's different from a search engine, which is a website that is used to search the internet. Instead, a web browser is a program on your computer that allows you to visit websites. You get to your web browser by clicking on its icon. From there, you enter web addresses, and the web browser displays the web pages for you. The web browser is the most important piece of software on your computer because every web page runs through it. So a faster web browser means that you'll save time on every web page you open. Installing a new web browser is free and only takes minutes. So take a moment to choose a web browser that you like best today.
Okay, let's close. How does a DNS request work? So yeah, we just watched a video about it, but it was quite complicated. So let me read through it. As we already saw, when you want to display a web page in your web browser, it's easier to type a domain name and then an IP address. Let's take a look at the process. Typing mozilla.org in your browser's location bar. Your browser asks your computer if it already recognizes the IP address identified the domain name using a local DNS cache. Means you if you have ever searched mozilla.org in your browser, it will get saved in cache memory. If it does, the name is translated to the IP address and the browser negotiates contents with the web server. End of story. If your computer does not know which IP address is behind the mozilla.org name, it goes on to ask a DNS server whose job is precisely to tell your computer which IP address matches each registered domain name. Now that the computer knows the requested IP address, your browser can negotiate contents with the web server. Okay, so that was a deep dive. That video was a deep dive. It is an approach. Okay, so there are different type of DNS servers, as the video mentioned. I think there were 4. So let's jump back here. Okay, which one? It was read about how one part of the web interacts with another. So this is it. Computer connects to the internet are called clients and servers. A simplified diagram of how they interact might look like this. Client, server, request, response. Clients are the typical web users internet connected devices. For example, your computer connected to your Wi-Fi or your phone connected to your mobile network, and web accessing software available on those devices, usually a web browser like Firefox or Chrome. Servers are computers that store web pages, sites, or apps. When a client device wants to access a web page, a copy of the web page is downloaded from the server onto the client machine to be displayed in the user's web browser. Wait a minute. It says when a client device wants to access a web page, a copy of web page is downloaded from the servers into the client machine to be displayed at the user's web page. So if it downloads a copy of the web page to my device, so why can't I get React's front-end code when I inspect it? Okay, this is a good question I should ask in my class. I'm also gonna ask about some more questions. So this is one of them. The other part of the toolbox, the client and servers we have described above, don't tell the whole story. There are many other parts involved and we'll describe them below. For now, let's imagine that the web is a road. On one end of the road is the client, which is like your house. On the other end of the road is the server, which is a shop you want to buy something from. In addition to the client and the server, we also need to say hello to your internet connection. Allows you to send and receive data on the web. It's basically like the street between your house and the shop. TCP, IP, transmission control protocol, and internet protocol are communication protocols that define how data should travel across the internet. This is like the transport mechanism that let you place an order, go to shop, and buy your goods. In our example, this is like a car or a bike or however else you might get around. DNS, domain name system. Domain name system is like an address book for websites. When you type a website address in your browser, the browser looks at the DNS to find the website's IP address before it can retrieve the website. The browser needs to find out which server the website lives on, so it can send HTTP messages to the right place. This is like looking up the address of the shop. You can access it. HTTP, Hypertext Transfer Protocol, is an application protocol that defines a language for clients and servers to speak to each other. This is like the language you use to order your goods. Component files. A website is made up of many different files which are like the different part of the goods you buy from the shop. These files come into main types: code files. Websites are built primarily from HTML, CSS, and JavaScript, though you'll meet other technologies a bit later. Assets. This is a collective name for all the other stuff that makes up a website, such as images, music, video, Word documents, and PDFs. So what happens exactly? When you type a web address into your browser, for our analogy, that's like walking to the shop, the browser goes to the DNS server and finds the real address of the server that the website lives on. You find the address of the shop. Second, the browser sends an HTTP request message to the server asking it to send a copy of the website to the client. You go to the shop and order your goods. This message and all other data sent between the client and the server is sent across your internet connection using TCP or IP. Third, if the server approves the client's request, the server sends the client a 200 OK message, which means of course you can look at that website. Here it is, and then start sending the website files to the browser as a series of small chunks called data packets. The shop gives you your goods and you bring them back to your house. The fourth, the browser assembles the small chunks into a complete web page and displays it to you. The goods arrive at your door. New shiny stuff, awesome. Okay, is it a deep dive or not? I don't know. Order in which component files are passed. When browsers send requests to servers for HTML files, those HTML files often contain link elements reflecting external CSS style sheets and script elements referring external JavaScript scripts. Okay, it's important to know that the order in which those files are pressed by the browser as the browser loads the page. I think HTML files are called first, or as all the JavaScript files load after loading of HTML files. I think the browser presses the HTML file. Okay, I was right. File first, and then leads to the browser recognition. Any link element reference to external CSS style sheet, and any script element reference to scripts. Okay. Script element will be JavaScript. As the browser presses the HTML, it sends requests back to the server for any CSS file it has found from link elements, and any JavaScript file it has found from script elements, and from those the praises the CSS, then praises the CSS and JavaScript. The browser generates an in-memory DOM tree where from the praised HTML generates an in-memory CSSOM structure from the praised CSS and compiles and executes the praised JavaScript. As the browser builds DOM tree and applies the styles from the CSSOM tree and executes the JavaScript, a visual representation of the page is printed to the screen, and the user sees the page content and can begin to interact with it. So it was a deep dive, but never mind. So let's close this. Okay, I don't have to bookmark MDN web docs as I have already added it to my pinned pages. Now let's check. The section contains question for you to check your understanding of this lesson on your own. If you are having trouble answering the question, click it and review the material it links to. What is a web server? A web server is a physical hardware or computer machine where a website is hosted. Am I right? A web server. Okay, website is hosted, or maybe my phone is also a web server. Client or user and client both can be a web server. My server doesn't host website. Maybe let me see. Can a smartphone be called as a web server? Is it right to call smartphone or web server? Let me check. Let me Google it. Okay, it is a web server. So I'm not hosting a website, but my smartphone or laptop is a website. What is a network? Okay. A network is like, how I'm gonna explain it. It connects two different servers to each other to transfer data, request and response, etc. All the protocols. A network helps in this to connect point A to point B. A network helps it. Let me see. Hey, wait a minute. I clicked on a network. Now why it's opening internet page? Never mind. What is the internet? Internet is vast connection of cable underneath the ground, which helps in data transfer, request, response, and all the queries Okay, da 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 da, web technical, blah blah blah, blah blah blah, blah blah, la 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 la, baby shark, do 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 do. So yeah, I was right mostly. So let's go to the next one. What is an IP address? IP address is a unique address assigned to a device or a server or client. So the data requested by user reaches to IP address of the client, and when client returns data, it reaches user by its IP address, so data won't get lost in between the way. What is a router? A router connects a server or mobile device, computer, PC to internet service provider. Internet service provider, what is the internet service provider? Internet service provider, well, what internet service provider do is they connect router to, I don't know, they connect web to web, database, dataset. Well, I'm confused here, I guess. I might know the don't know the right definition. What? How does the hey? Okay, okay, okay. So we are here. A network of network. Where is ISP? Internet service provider. Okay, here it is. Okay. Yeah, to do that we will so we are connected to the telephone infrastructure. Next step is to send the message from our network to the network we want to reach. To do this, we will connect our network to an internet service provider, ISP. And ISP is a company that manages some special routers that are all linked together and can also access other ISP routers. So the message from one network is carried through the network of ISP network to the destination network. The internet consists of this whole infrastructure. So okay, so internet provider is a middleman that handshakes with other middlemen who knows someone who knows someone who knows where my data is. What are packets and how are they used to transfer data? Packets are when data is breaked into small bits of 6 digits and transferred by different paths. For when I request something, let me like if I want to download an image, then image will get break down into smaller bits and will get to me by different packets. And how they used to transfer data? Well, they travel to different paths. Let's say you want to go to point A to B, but from A to B there is much traffic, but there is a way which goes from A to C to B, which will take much shorter time. So you take A to B, C to B path. So that's how packets work. What is a client? Okay, client is maybe a website or a computer to which the request is sent. What is a server? I am a server. I am requesting data. Suppose if I am searching something, I am the server. Now I am going too fast. Well, I don't have much time. Let me see how much time now. Okay. Okay. Let me finish this really fast. What is a web page? A web page is literally what I guess. Okay, I got caught over the time because I'm running late for something. What is a web page? A web page is a document that displays information to the user when requested. It mostly displays HTML, CSS and JavaScript. What is a web browser? Web browser is used to search for websites or go to web pages. What is a search engine? Search engine knows what to search, like they have this data. It's like okay, it's like okay, it's like a dictionary. Yeah, get it. What is DNS request? DNS request is a handshake. When I search for a specific website, DNS request is sent to find that name, IP address, that website's IP address, and send me back the website. Which browser are you currently using? Mozilla Firefox. In your own words, explain what happens when you run a search on google.com. So when I run a search on google.com, suppose I have searched dog. So what will happen? I'm a server. Okay, I'm a user server. So suppose my IP address is 1111111 whatever. So my request will go to my internet service provider. My internet service provider will connect to what I can say, different okay, it will do a DNS handshake, I guess. It will search for where the dog is. Okay, my search engine, oh sorry, I'll type something in my search engine, then my search engine will collect all the data from the internet that includes word dog, and it will go to the all the database and collect their information and display it in front of my web page, which will return to my ISP again. So this is what happens. These are additional resources. I won't go deep into this as I'm running late for something important. Okay, so mark is complete. I think I'll once again summarize this because I'm in hurry right now. So that's all for now. I'll be back with the next chapter, installation overview. So bye bye, take care.